So we're going to start off today looking at the stair regulations. So again, it's on the top of page 116 if you want to fill it out in class, otherwise you'll have to do it whenever I upload the PDF. Okay, stairs regulations. So for the ease of use, building regulations ensure that the step size is similar. Okay, so it has to be similar to a kind of person's natural stride or natural walk. Okay, so samples of this would include that the pitch should not exceed 42 degrees. Okay, so you can see here we're looking at the dotted red line. So the pitch of that there is 42 degrees. Optimum is 37 degrees. So it should say 37 in here. The rise shall not exceed 220 millimeters. Okay. So the rise should not exceed 220 millimeters. Again, the optimum here is 175. Then the going should be less than 220. Ideally, it should be about 250. And then twice the rise plus the going is 2R plus G. That must be between 550 and 700. Okay, so we'll just recap that again because a few people came in late there. So we're looking at the top of page 116. So there's two basic stair regulations here that you need to take note of. Okay, first of all, basically what we're saying here in the first part of the bullet point is that for the ease of use, building regulations ensure that the step size is similar to a person's natural walk or natural stride. So some of these regulations include these regulations below. Okay, you need to sketch this one here, which is that the pitch should not exceed 42 degrees. The optimum pitch of the stairs should be 37 degrees. Okay, and then the other one then is, I suppose these two are kind of together here. The rise should not exceed 220. So you can see the rise should not be any more than 220. The optimum is 175. Again, this is all based on a person's natural stride. And then the going should be no less than 220. Again, optimum should be 250. Okay, so obviously the step should be longer than it is high, if you like. Okay. And then another measurement that sometimes comes up is that twice the rise plus the going, so twice the rise, so two rises plus the going, must be between 550 and 700 millimeters. Okay. So 13 on the bottom of page 116, again more building regulations. So to prevent a person from falling from the stairs, there's a couple of things we need. You're going to have to write these down. So firm guarding must be provided. The balusters must not allow a 100 millimeter sphere to pass through them. So in other words, these are the balusters coming down here from the handrail to the stairs. The gap between them should not be any more than 100 millimeters. Okay. In other words, it should be hard to pass an object that is 100 millimeters or bigger through in between. Okay. The idea of this is that nobody can fall. The guardrail must be securely mortised into the newel post. So this is the rail here. It needs to be mortised or jointed into the newel post. Alright. A handrail should be provided on the wall side of the stairs for any stairs that's wider than 1000 millimeters. So if you have a really wide stairs and the other side is up against a wall, you should put a handrail should be screwed onto the wall basically. Okay. In most houses, if they're up against the wall, they wouldn't have a handrail on both sides. Okay, the stairs wouldn't be wide enough that you'd need it. Alright. Garden must be designed so that it cannot be easily climbed by children. Okay, so obviously you need to be aware of children climbing stairs. They can get hurt. And then the horizontal rails should not be used. Okay, so the horizontal rails should not be used. In other words, rails that go alongside. So instead of the balusters coming down here, you could have rails that go from the newel post to the newel post. They should not be used because it leaves too big a gap, basically. Okay. So again, that's just the joint going into the newel post, and then the type of rails you should not use. Okay, going horizontal. Okay, because there's bigger gaps in between them. Okay, page 117, So there's answers here for 14, 15 and 17. Okay. So building regulations. So other stair regulations include, so this is A to G for number 14. A maximum of 16 steps is not permitted without a landing. So remember we looked at a landing area last week. The nosing must project a minimum of 16 millimeters beyond the riser. So basically the nose of the step should be at least 16 millimeters out from the rise. You'll notice that in your stairs at home, the steps overlap the risers. Okay. The handrail must be located 840 to 900 millimeters above the pitch line. So 900 is an easier measurement to remember there. Stairs can have a minimum width of 800. Okay, so the stairs cannot be any narrower than 800 millimeters. A minimum of 2 meters headroom. Okay, so if you have a story and a half house, okay, and you're going up and you have a converted attic, you need to be aware of headroom. All right, so you need at least 2 meters is the regulation. And the landing must be provided at the top of every flight. Okay, so for every flight, so remember you can't have any more than 16 steps in a flight of stairs. So obviously if you have stairs that's going maybe 2 stories high, you'll need to have a landing area. Alright. Again, these are just some of the measurements. So 900 millimeters. Okay, is the distance from the kind of pitch line to the handrail. And you can see here that the width of the stairs should be no more than 800 millimeters. Moving on. Again, that's just the 2 meter rule. So you can imagine that if you have a story and a half, that your ceiling above is going to be sloped with the kind of slope of the roof. So you need to be aware that you need to have enough headroom if you're converting an attic, so that you can comfortably go up without having to be crouched over. Okay. Next one. So where a door opens onto a landing. So if you have a door opening onto a landing, so you'd have this mainly, you wouldn't have this in a house per se, you would have it in, I suppose, industrial buildings or office buildings or even shopping centres, I suppose. Okay. So where a door opens onto a landing, so you have a door here, there's a landing area. So you can imagine there's a flight of stairs coming up here. You have a landing area, then there's another flight of stairs going up there. Okay, you have a door here. The door obviously needs to open onto the landing, so you need a minimum space of 400 millimeters free of obstruction, so the door can be opened. All right, this is on question 16 on page 117 of the book. Okay, you have to fill in a missing measurement as well, which is 400. And you can see there's the door opens, you need a clear space. Okay, and it cannot open too close to the stairs because obviously someone could be coming down as somebody opens the door. Okay, in other words, you wouldn't hit them. Alright, moving on then. So this is just kind of a rough idea of what the stairs looks like. A few measurements. Again, if you haven't done number 15, there in your book on page 117, the width measurement is 800. And the measurement from the handrail to the pitch line should be 900 millimeters. Okay. Again, we're looking, the maximum kind of pitch of a flight of stairs should be no more than 42 degrees. Okay, again, 900 millimeters from the step or the pitch line up to the top of the handrail. And then it should be at least 2 meters headroom the whole way up. As well as that, the baluster should be close so that an object that's more than 100 millimeters should not pass through. Okay, that's a safety regulation. Okay, page 118. So we're looking here at tapering and winder steps. Okay, so this is basically a step that's going around a corner that doesn't need a landing area. Okay, so for threaded tapered stairs, the minimum going at any part of the stairs is 75 millimeters. Okay, so 75 millimeters. If the stairs is less than 1 meter wide, the going is measured from the center. Okay, so if the stairs is less than 1 meter wide, we measure the going from the center. So you can see this red line that goes through it. Alright. So this is we're only talking about winder steps, or if you like to call them a corner step. Okay, you can see that the steps are tapered. They all come into a point here. Okay, so the step, for example, is narrower on this side than it is on this side. Alright. The third point there, if the stairs is greater than 1 meter wide, the going is measured 270 millimeters from the side. Okay, so if it's more, it's measured 270 millimeters from the side. Alright. All taper steps should have the same taper, and the winders should be placed at the bottom of the flight to minimize any risk of injury. Okay. Now, these steps very rarely come up in exams, guys. Okay. You'd very rarely get a tapered or a winder step, but you just cover it just in case it does come up. It has come up once before. As I say, it's very unlikely it comes up. But really, all you need to know about a tapered stairs is the 5 bullet points we have here. And I don't even think the book would ask you to sketch. No. Okay, so you don't even need to put the sketch into the book. But it is important to remember about the going, that if the stairs isn't any more than 1 meter wide, that you take the going from the center. And if it is greater than 1 meter wide, we take the going 270 millimeters basically from the corner. Okay, so you can see the distance here from the side of the stairs in here is 270 millimeters. Okay, again, it'll be the same from the other side. So measuring 270. And this line here in the middle, guys, that is just, I suppose it's this here middle line. Alright, so they just put that there in there as well. Okay, so for stairs that's less than a meter, you take it exactly in the middle. If it's greater than that, you come in 270 millimeters basically from each side, and you get these two red lines. So you have two measurements to take because the stairs is a lot wider, and they also take the middle line as well, just as a backup measurement. Okay. So there's two types of stairs. There's a closed string and a cut string. Okay, what's the difference? The difference is in this area here. Okay, so remember the string is kind of the board here that kind of covers underneath the steps. You can see the closed one, you can't, if you're standing in the hallway downstairs and you look at the stairs, you can't actually see these steps because it's covered. Alright, so you can see here that the string comes higher than the steps, so you wouldn't be able to see the steps. Whereas on this one, the string is cut to the shape of the steps. Alright, so you can actually see the balusters going the whole way down to each step. Okay, so the only difference in the closed and the cut string is down around the string area. Alright, so very simple. So you can see the red flashing area there, that was the closed string, and then the cut string then you can see is cut around the shape of the stairs. Alright. Stair calculation, something that does come up if a stairs question comes up in your exam. So the important thing to remember from what we've learned between today and last week, the maximum number of risers, in other words, the maximum number of steps in a flight of stairs can be no more than 16. So you need to remember that. The rise, okay, you have 220. Alright, and then the going is can be no less than 220 as well. Again, remember the optimum is 250. And then the last calculation is, the 2 times by the rise. Okay, so if you remember, if we go back, we had this calculation today, which was here. Okay, that twice the rise, so 2 times the rise plus the going, so it's 2r plus g. Okay, must be between 550 and 700. Okay, so in that red box that we've looked at there, basically what we have is, or this box here, it's in the red box in your book there, guys. It's just the calculations that you need to remember if you're doing a stair calculation. Now there's a sample exercise on 19 and 20, so we may as well do them now. We have plenty of time. So before we do them, so the stair calculation, so there's, I suppose I've broken it into 3 steps. I suppose there's kind of 4 steps, but there's 3 steps here. So step 1 is to calculate the height of the riser, in other words, the height of each individual step. So you divide the height to be climbed, which is the total rise. So from ground floor up to the ceiling height. Alright, so you divide that by 16 because you can't have any more than 16 steps in a flight of stairs. Then 15 and then 14 until you get an even number. Okay, so you want to get an even number. Usually between 16 and 13 steps would be enough. Alright, otherwise you would have to have a landing. Step 2 then is to calculate the going, which is kind of the length of the steps. Okay, it'll tell you how many threads you need. So to calculate the going, you have to remember the number of threads will be one less than the number of risers. Okay, so in other words, you'll have more risers, so kind of depth to the steps. Alright, so start by testing if the total number of threads multiplied by the optimum going of 250 is equal to the distance to be spanned. So that's just the total going. So the distance to be spanned is from the point the stair starts to the point it ends. Okay, if not, you need to try the nearest round number. Okay, so a bit of heavy going here, so hopefully whenever we do the stairs calculations it'll make a lot more sense. Step 3, use the formula. So 550 greater than or equal to 2 times the rise plus the going needs to be less than 700. So to test your measurements for the rise and going. Alright, so this is the formula. If the answer is greater than 550, then the going will have to be increased because it can't be any less than 550. And if the answer similarly even is above 700, then the going will have to be reduced. Okay, it can't be any more than 700. So if you look there in the bottom of page 118, we have a calculation here. So obviously there's no stairs in the image, but we have a few measurements taken. Alright, so in the space provided, calculate an appropriate rise and going for the overall stairs details shown in the diagram. Alright, so we have a couple of measurements there that we need to work off. Okay, and you can see there's a red box there for your stair calculations. There's 4 different things you need to remember. Okay, so this is what we're given. So you're given a plan, which is here, and you're given your elevation. Okay. So to calculate an appropriate rise and going for a stairs to fit into the space that's outlined here, we're going to use the formula. So first of all, we need to figure out the total rise, which we're given as, so from ground floor up to the first floor, you have 3,150 millimeters, so you can write that down. So that's your total rise. The total going we're given from where the point of the stairs starts to where the point of the stairs will finish. Okay, so the stairs will be going up here at this angle here. That is 3,750. So remember, a flight of stairs can have no more than 16 steps. So if we divide our total rise by 16, so hopefully if you do that, you get 196.87. Now remember, we wanted to be rounded off to a nice even number to make it easier. So we try 15 steps and you get a nice even number of 210. Okay, so the total rise divided by 16 steps gives a rise for each step of 210 millimeters. Is this acceptable? It is, because remember, the regulations state that it needs to be no more than 220. Okay, so that's the first part done. So we know what our rise is going to be. We now need to find the going. Okay, so similarly, the going measurement we're given is 3,750. So yeah, okay. So to calculate the going, so the optimum going, remember, was 250. Yeah, it's on the screen there. So 250. We're going to multiply that by 14. That gives you 3,500. Okay, so I'm just doing it here. Yeah. Alright, so guys, if you have a calculator, you can do it. Is this acceptable? It is, because it meets the regulations. Alright. Now remember, actually, I'll go back there something just to explain. So remember, for the rise, we got that the total steps we're using is 15. So our flight of stairs in this case is going to have 15. because it's a nice round even number to work with compared to what 16 was. Alright, remember that the going is going to be one less than the steps. Okay, that's why I've divided or multiplied this by 14. So in other words, if I went with this measurement for the steps, 16, I would have multiplied to get the going by 15. It's always just going to be one less. Okay, so just to clear that up as to why this was multiplied by 14. Okay, so it's going to be one less than whatever amount of steps you're going with. Alright, so again, the measurement there we got was 3,500. So then we need to do our last calculation after we get the rise and after we get the going, and that is the formula. So again, remember, it is going to be twice the rise plus the going. So yeah, remember, it needs to be between 550 and 700. So 2 times the rise, which we got was 210. So 2 multiplied by 210, and plus the answer we got for our going is the optimum. So we're going with the optimum, which was 250. Alright. Once you do that formula, you get 670 millimeters. So is this acceptable? Yes, it is, because it's between 550 and it's between 700. Okay. So that is the calculation. So guys, there's a bit of thinking in it, but whenever you get used to it, it is fairly straightforward. It's the same calculations the whole time. So you're going to find the steps, you're going to find the going, and then you're going to use the formula then to check twice the rise plus the going. Okay. So that is what we get. So we'll go on and do number 2 there. Guys, anyone got any questions on the first calculation before we do move on to the second one? No? Right. No? Okay. Right, so we'll move on to the second one. This is the last part of today's class. So in the space provided, calculate an appropriate rise and going for the overall stairs detail shown. So guys, it's something similar. Okay, obviously it's a slightly different image. We can see there's a door in the way, so obviously the stairs is restricted by the door in terms of its pitch. Alright, so we need to bear that in mind. So calculate an appropriate rise and going for a stairs to fit in the space provided below. So you can see we have a measurement for both. So again, we'll write down our key measurements. So the total rise is 3,200. The going is, the maximum going that we can use is 3,750. Okay. The usable going then. So yeah, so we need to remember. If you remember back to one of the slides that I showed you earlier, I think it was maybe on page 117, might have been question 16 there. If there's a door area, we need to leave a space of at least 400, because in other words, if someone's coming down the stairs and someone opens the door, you can have a collision. You can have a collision. So out of our usable going, which is 3,750, we need to take 400 away from that. That leaves us with 3,350 to work with. Okay. So again, find the rise first. So 3,250 divided by 16, which is the maximum number of steps we can get, and straight away we get a nice even number of 200, so we can use this. It is acceptable. Then we have to calculate the going. So our optimum going again is 250. So we're going to multiply that by 1 step less. So if we use 16, it's going to be 15. So 250 multiplied by 15 gives you 3,750. So is this acceptable? Just about. Okay, so it's just about acceptable. The measurements that we are using once we take the 400 away again was 3,350, so 3,350. So we're going to divide that by, again, 1 step less, which is 15. So that gives us an answer of 223. Okay. So 223. So it's just about enough for the going, because it is between 220 and 250. Okay, it's just about between 220. It's 3 millimeters above. Then we have to use our formula to check the rise plus the going. So our formula, 2r plus g. Again, it has to be between 550 and 700. So 2 multiplied by 200. So 200 is the answer we got for our going. plus 223, which is the answer. Sorry, yeah, which is the answer we got here for our going. So we'll go over that again. So 2 by 200 is twice the rise. So our answer for the rise was 200. So 2 by 200 gives you 400 plus 223, which is what we got for our going. Altogether, that adds up to 623, and that is between 550 and 700, so it's acceptable. So, guys, as you can see, there's 3 steps to calculating, I suppose, to basically get measurements for a stairs. So if you were building a new house and you were getting someone to make stairs for you and they asked you what the measurements were, they would ask you for the rise. Well, first of all, they'd want the total rise and the initial going, which we were already given because we can't physically measure it. So 3,200, and then the going was 3,750. Then they would also want you to tell them what the usable going is for the going for each step. So you would divide 3,200, which is the height from floor to the first floor. Divide that by 16. You get an even number, that's acceptable. If you don't get an even number, you try 15 and 14 until you do get an even number. Then to calculate the going, we know that the optimum is 250. So we're going to multiply that by one step less than the going, which is 15. So we get 3,750, which just about fits our area. Okay, and then we have to remember though, we can't divide 3,750 by 15 because we need to take a 400mm area out because we don't want the stairs to end exactly at the end of the door. The answer then we get for our going is 223. Okay, and then to get your final measurement there, for the overall pitch line, you have to check twice the rise plus the going. So twice the rise plus the going. Again, it needs to be between 550 and 700, and the answer you get there is 623, which is between 550 and 700, so it is acceptable. Okay. Finally, guys, this isn't in your book, but it's just something I added on. A little bit like winder steps. It's unlikely to come up in the exam, but it could come up. Is concrete stairs. So concrete stairs are more popular in kind of modern house construction. They've been used in, I suppose, industrial factories and shopping centres and that kind of thing for years. But people are starting to use them in the house and then decorate them, I suppose. So there is a possibility it could sneak up in exams. So they provide excellent sound insulation over timber stairs. They're more solid, so there's less noise. You can put a carpet finish on them if you want. The concrete stairs can be either cast on site or prefabricated in a factory and lowered into position on the site using a crane. So in other words, they can make them on site by mixing the concrete and setting it, like this one, or you can buy it that's made in a factory and transport it. Okay, that's kind of what a concrete stairs looks like going in. So there's a lot more work in it. Okay, again, there's a concrete stairs. You can see here we have a landing area. Okay, or you have a landing area there. Landing area just where the steps are turning. Okay, it's a lot cheaper than having a round stairs. And finally, yeah, that's it. Okay, so that's it, guys. I'll stop the video here.